Howdy guys, from Lab6, we will start to implement Verilog simulation. Since you already taken 248 before, so I think you're already familiar with how to use the Verilog. First, we need to install iVerilog and GDK Wave on the Raspberry Pi board with this command. Okay, let's go to the questions directly. So for problem 1, 2, 3, and you need to design the half adder, 2 to 1 mux, and 2/4 decoder. And for half adder and 2 to 1 mux, you need to use the structural design. And for the 2/4 decoder, you need to design with the behavior model. I will talk about the 3 models of the Verilog design. First is the structural model. Structure model is a described design using the model instances, which is similar to the schematic or circuit diagrams of the digital circuit. And Verilog uses the primitive gates to compile and synthesize the program. Actually, the structural modeling is the lowest level of the abstractions obtained using logic gates. The language supports multiple gates, such as AND gate, OR gate, NAND gate. Normally followed by the gate. We can define an instance name to name this gate. And in the parentheses, we can include the outputs and inputs of these gates. You can also use the tree-state gates at multiple output gates, such as buff and NOT gate. Okay, next one is the behavior model. Behavior model is the highest of the level abstraction that completely depends on the circuit behavior or on the truth table. We can describe the design when you know how the circuit behaves. In fact, you can design this model and without knowing what is the inside components of the hardware. Even though actually it is the closest in terms of natural language understanding of the circuit functionality. And for the behavior language, it contains the initial or always statements, the procedural statements in the module are executed sequentially. Next one is the data flow model. Actually, we seldom use this model. It is a medium level abstraction, which is achieved by defining the data flow of the module. Actually, it is similar to the structural design, and normally it is simple to implement and can be easily translated to structural design, such as in the case of the combinational circuits. And the combinational circuits use continuous assignments, and we can just assign output equals to the input and the logic. And normally we can use add, subtract, and or XOR that the logic expression. Okay, for the half adder, half adder, the output is the sum and cout, and the input is A and B. So for the first one, I think you have learned in the class, you can write the truth table first, and you can convert it to the expression and draw the circuit. So you can design the half adder with the structure model based on its circuit. For 2 to 1 max, the output is out. The input is a 2-bit input in, and is a 1-bit selection signal. So we can select the input. If selected is 1, we just output the first bit, and if selected is 1, we can just output the second bit. And so you for the 2 to 1 max, you need to use the truth table and get the expression of the logic and draw the circuit by yourself. And for 2 to 4 decoder, the output is 4 bytes out. The input is 2 bits in, and we need to use the behavior model. So just in the behavior model, if input is 0, 0, the output is 1. If the input is 0, 1, the output is 0, 0, 1, 0. And followed by this logic. I think that is all for Lab 6. Thank you.